So here's our objective, and here's our topic, and these equations, here's they are, all right? And by solving them, you're going to be given some stuff. You might need to calculate a concentration, a rate constant, or a time, all right? And that's what our goal is. All right, here Dr. Square is solving for a concentration of hydrogen peroxide. That's our goal for this. I want to review real quickly that here are the graphs for the different orders of equations. It's a linear relationship, so I generally am using this an equation that looks kind of like this, and therefore we're just going to review real quick a couple of these equations. So I'm solving for y here, so I'm going to plug in x. All right, I'm going to multiply 2 times 5 and add 3, and I'm going to multiply and then add, and I get 13. All right, here I'm solving for the slope. I've got two variables. All right, I'm going to substitute, then I'm going to add 6.7, that's what I'm going to get, and then I'm going to divide, and I get my slope is that. All right, now remember, here are the equations that we're using on the reference sheet for the AP exam. These three. This is 0, first, and second order. All right, and these are the equations written out. All right, I just said it, and those are the graphs that goes with that. Should all be review. All right, now, and I read the problem, you first thing you're going to look for is what's the order of the reaction. And that tells me what equation I'm going to use. I'm going to use this one, all right? And then I'm going to want to make sure I read through and figure out what I'm given. This is the rate constant. Initial is this. How long means a time. And here is the final concentration. So since it's second order, this is the equation I'm going to go use. This is my rate constant. It goes there. How long is this? This is the initial, and that's the final. All right. So then I'm going to substitute in. I get this. And this may look gobbledygooky, but it's really simply a division problem, a division problem. So I do that first, subtract them, and then I'm going to end up with another division problem. All right. All right, I did it. I divided and I got this, and subtracted. I divided and subtracted and got this. Now the next thing would be to divide both sides by 0.015. 0.15. All right. All right. Now I'm going to cancel things out. My molarity concentrations are going to cancel, and over here this whole variable n units are going to cancel, and I'm going to be left with this 22.2 seconds, and that would round to 22 because of sig figs. All right. All right, here we go. What's my order of reaction? It's first order. That means I'm using this equation, the natural log of the concentrations of A or X or whatever it is we're talking about. I'm going to read the problem. Ooh, this is my K value. Here's my initial. Then what is it? What is it? It's concentration. This is asking for concentration. Here's a time. So, since it's first order, this is what I'm going to use. So my initial goes there, my K goes there, and my time goes there. And I'm looking for the final concentration, or the concentration at a given time. All right, I'm going to plug in. I get this. And this may look like a lot, but it's simple. It's stuff you've done. You're just going to multiply these two numbers, divide by this, and then take the Euler's number, or e to the x of this, whatever you get for your thing, to get rid of the natural log. These numbers will cancel, and then I'm going to simplify. This is going to simplify further because I've got two negatives, so that would become positive. All right. And now I ran out of room on this slide, so I'm going to bring it up here. And Now the next step is to minus this number from both sides. All right, and these two things would become a bigger negative. And here I am, the natural log of x is this. Now to get rid of the natural log, you have to take e to the x of both sides. And these things will cancel. And I want to talk briefly. Here's the button I'm looking for on a calculator, right? It's e to some power. So you want to be able to therefore plug it into the calculator so it looks kind of like this. E raised to this power, right? And then I'm going to do it, and that's going to give me my answer, which is going to be this. Now I have 3 sig figs, so this would just round to 0.0175 molarity sulfur dioxide dichloride. All right, and that's how we do it. I hope this has been helpful. Here are my sources.